to do the notes for lesson 2-4, find the percent of a number. These notes begin on page 103. I can find the percent of a number by reasoning about percent as a rate per 100 and by using bar diagrams, ratio tables, equivalent ratios, and double number lines. Remember, using a 10 by 10 grid and bar diagrams help us represent the percent of a number, because percent means per is of cent is 100 per 100. So a 10 by 10 is 100 squares. Learn, find the percent of a number. The question is, 50 people were surveyed and asked to vote on their favorite flavor or sherbet. The results are shown in the table. Here's the table. Their flavors: lemon sherbet, 20% had as their favorite. Orange was 26% as their favorite. Peach was 14% as their favorite. Watermelon was 40% as their favorite. Method 1. Use the bar diagram. Find the number of people who prefer lemon. You can use a bar diagram. The bar is separated into 10 equal sections. The whole is 50 total people. So all the people that were surveyed were 50 people. And as you can see, it would be shown that 50 people represents 100%, everyone that was surveyed. So each section represents 50 divided by 10, or 5 people. So each section or each unit represents 5 people. The percent is 20%, and the part is 10 people, 2 sections, 5 people each. The bar diagram shows that 20% of 50 is 10. In context, 10 people, or out of the 50 surveyed, which is 20%, prefer lemon sherbet. Why is the bar divided into 10 sections? Is there a different way you can divide the bar to solve the same problem? Explain. Why is it divided into 10 sections? Since the percentage is 20%, we can create and divide the bar into 10 sections and then cover 2 of the sections, or shade in 2 of the sections to show 20%. Continuing on page 104. 104. So here's another method. So we could do a bar diagram. We could also do a ratio table. So you know that 100% of 50 is 50. You need to find 20% of 50. So you scale back or scale down to find the 20% of 50, but by dividing both 100 and 50 by 5. So we know 100% would equal 50. How much would 20% equal? We would scale it down or scale it back, and that means divide by 5, and we would find 20% would equal 10 people. Another way, method 3, would be using equivalent ratios. So we would let n is just a placeholder. It is a variable, we could call it, to show that we're looking for this answer. It's a placeholder. So let n represent the number of people who prefer lemon. So the percent is so many people out of 50. 50 represents the 100% because 50 people were surveyed. 20% would be the number of people that prefer lemon. So we would set it up as an equivalent ratio, 20 to 100. So these are both percents. 20, we're finding 20%. We know the 100% because that's 50. So if we take a look at this, we can say, okay, we can scale it back. 20 over 100, and we can take the 100 down to 50 by dividing by 2. We can do the same thing for the 20. We have to divide by 2 because 100 divided by 2 is 50. Divide 20 by 2. And so in this case, we would find that 20 divided by 2 is 10. So the n, or that placeholder, would be 10, and that would answer the question that 10 people prefer lemon. Method 4 is using a double number line. So you would draw the double number line. The bottom number represents the percent. So here's the percent: 0, 10, 20, 30, all the way to 100. You would use increments of 10 to draw tick marks and label the percents. The top number line represents the number of people. So label the tick marks that corresponds to the 100% on the bottom line with 50. So we know 100% of the people that were surveyed would be 50 total people. 0% of the people surveyed would be 0. And so with these tick marks of 10, 20, 30, 40, all the way to 100%, we can go ahead and we can fill in the numbers that would work with the upper number line tick marks. So the top number line represents the number of people. So the label of the tick marks that corresponds with 100 is 50. Since there are 10 increments, the value of each tick mark at the top increases by 50 divided by 10, or 5 units. So you would count by 5s: 0, 5, 10, 15, 20, all the way to 50. And that would show that 100% would be the 50, 50% would be 25, and so on. The double number line shows that 20% corresponds to 10 people. Using this method, 10 people out of 50 prefer lemon flavored sherbet. Think about this, and which representation helps you best visualize this problem? So there's 4 different methods: double number line, equivalent ratios, ratio table, and bar diagram. Those are the 4 that you could use. So we could write down the bar diagram. These are the 4 possibilities: ratio table, and you can choose which one helps you best visualize and understand this: equivalent ratios and double number line. You can see which one helps you best of these 4 that we just went over, the 4 possibilities. Can you think of a situation in which it might not be advantageous to use that representation? So it might not be the best place to use that. Continuing on, page 105. On page 105, here's an example of how to find the percent of a number. The graph shows the types of snacks that students at York Middle School bring with them to school. Suppose there are 300 students in the school. So this entire circle is representation of 300 students. I always like to write down how many students it represents. And snacks, we have 15% bring cheese as a snack, 17% bring veggies as a snack, 15% bring cookies as a snack, 18% bring chips as a snack, 12% bring no snacks, and 23% bring fruit as a snack. Continuing on, how many of them bring cheese for a snack? So we would go back to our graph and we would say 15%. So first we identify the part, the whole, and the percent. The part is unknown. Part is unknown. We don't know how many of the 300 would bring the cheese. All we know is the percent, which is 15%. We know the whole is 300. So there's a couple different methods you can use. One of the method is to use a rate per 100, or mental math. So the percent is 15%. This means that for every 100 students, 15 of them bring cheese for a snack. This is the rate per 100. So you could say 15 of the 100, 15 of the 100, 15 of the 100. And if I take a look at this, we had 300 students total. So here's 100 students, and we're breaking it into 3 separate sections. And we can say 15 of the first 100 bring cheese, 15 of the second 100, 15 of the third 100. And we can multiply those by 3, and we would find out that 45 students bring cheese as a snack. So we could do some mental math with that. We could also take a look and say, okay, equivalent ratios. Solve and write the equation stating that the ratios are equivalent. Let n represent the number of students who bring in the cheese as a snack. So it's that placeholder again, that variable. So cheese is n because we don't know that number, but we know the total students. So we don't know how many of those 300. But we do know 300 would be the 100%. 15% would represent how many bring cheese. So we'd set it up as an equivalent ratio, and we would say 15% over 100%. And we know that if we take 100 and multiply it by 3, we would get the 300. We would do that also for the 15 times 3. 15 times 3, when we multiply it, does come up as 45, same as what we had for the first method. And so we would say 45 students bring cheese as a snack. Check. Approximately 11% of the US population is left-handed. If there are 700 students at the middle school, about how many of them are expected to be left-handed? I'm going to show you the 2 different ways. The first method could be the rates per 100 or mental math. So we could say that 11% for 100, we have 700 students. So we could say 11% times the 7 groups, because it would be 11 out of the 100 students, and we would need to get that to over 700. So we could say 77 students. The other way, that would be the first method. The other method would be using the equivalent ratios. And we would set it up as we did up here. And we would say there's 700 students. We don't know how many are left-handed, but we know 100% equals to 700. And we know it's 11%, or 11 of the 100. And so 100 times 7 equals 700. We would do the same thing here. 11 times 7 would equal 77. So 77 students are left-handed. Continuing on. Example number 2 on page 106. Find the percent of a number. What is 30% of 240? This part is unknown. The whole is 240. The percent is 30. So we could use a bar diagram. This is one method. So you would draw the bar diagram into 10 equal sections. The whole is 240. So each section would represent 24, because we would take the 240 whole and divide it into the 10 sections. So each section is worth 24. Each unit is worth 24. Shade 3 sections to represent 30%. And so that would show that we have 10%, 10%, 10%, or 30% total. 24 times 3, or 24 plus 24 plus 24. And we would find that 72 would be 30% of 240. Method number 2 would be using a double number line. The bottom number The bottom number line represents the percent. So we have that percent and it's broken into 10, just like what we did up here with the bar diagram. So 10, 20, 30, all the way to 100%. So each increment of 10 is to draw the tick mark and label the percent. So like I just said, 10, 20, 30, all the way to 100. The top number represents the number that corresponds with each percent. So label the tick marks that corresponds with the 100% on the bottom line with a 240. Since there are 10 increments, the value of each tick mark on the top number line increases by 240 divided by 10, or 24 units. So if I have 100%, it's going to be 240. If I have 50%, it's going to be 120. 0% is 0. But if we take the 240 and divide it by 10, it would give us the numbers that would be in between each, and they would increase or decrease by 24. So 30% we would find here in the bottom. 30% would be 72, and it would correlate between the two. Third method, use equivalent ratios. So write and solve the equation stating that the ratios are equivalent. Let n represent the unknown part. So we don't know how many of the 240 would be 30% of the 100, just like what we did with the other methods or the other examples. So we would say 100% equals 240, 30% equals what? And we would take a look at this. 100 times 100 times 2 and 4 tenths would equal 240. We would do the same thing to the top. 30 times or multiplied by 2 and 4 tenths would equal the 72. So that means 72 is 30% of 240. So what is 70% of 580? Use any strategy. I like to use the equivalent ratio, so that's the one I'm going to use. So I will set it up as I'm not sure how much 70% would be, but I know I'm looking at the 580. The 580 would be the 100%, and the 70% would equate or be on the top where we're not sure of the number. And so we would go ahead and we would say 100 multiplied by 5 and 8 tenths would give us 580. If we are taking a look at doing the same to the upper numbers, we would multiply by 5 and 8 tenths, and we would come up with 70 times 5 and 8 tenths would be 406. So 406 would be 70% of 580. Continuing on page 107, example 3, find the percent of a number. You can also find a percent of a number when the percent is over 100%. What is 145% of 320? The part is unknown because we're not sure. That's the what is. The whole is 320. The percent is 145. Use a ratio table. You know that 100% of 320 is 320. That means all of 320 is 320. You need to find 145% of 320. Use a ratio table to scale back from 100 to 1% and then scale forward to 145. So by using my ratio table, I would start with 100% is 320. And I would use this, and this is where I would start. 100% is 320. I would scale it back to 1%. So 100 divided by 100 is 1. 320 divided by 100 is 3 and 2 tenths. And then scale up. We need to get to 145%. So 1 times 145% is 145. 3 and 2 tenths times 145 would give us the answer of 464. So that's one way to figure this out. Another way would be using equivalent ratios, just like what we were doing in the previous problems. Write and solve the equation stating the ratios are equivalent. Let n represent the unknown. So we don't know how much 145% of 320 is, but we do know 320 is the whole, and that is the 100%. We need to find the 145. So if I'm taking a look at the equivalents, I would say 100 to get to 320, we need to multiply by 3 and 2 tenths and do the same thing for the top number, 145. 145% times 3 and 2 tenths would give us the 464. Check, what is 275% of 4? So one thing I can do, I could use a ratio table, or I could do the equivalent ratios. And if I'm doing equivalent ratios, I don't know what the answer is, but I do know that the whole, I want 275% of 4. The whole is 4. This would equal 100%. 4 is equal to 100%, but we want 275%. So what we would need to do is we would need to take and divide 100 by 25. So we're dividing by 25. We need to do the same thing to the top. So I would take the 275 and divide it by 25, and I would come up with an answer of 11. 275 divided by 25 equals 11. Continuing on, this would be page 108, example 4 at the top. Find the percent of a number. What is 25 hundredths of a percent of 58? So this is percentages less than 1. The part is unknown. The whole is 58. The percent is 25 hundredths of a percent, or 1/4 of a percent. Use a ratio table. You know that 100% of 58 is 58, so you would need to find 1/4 or 25 hundredths of 58. And you can use the ratio table to scale back to 1% and then scale again up back again to 1/4. So we would start here. We know 100% is 58. And to go to 1%, we would divide by 100 and divide by 100. So 1% equals 58 hundredths. And then we need to go to 1/4 of a percent, or 25 hundredths of a percent. So we need to scale back again and divide 1 by 4 and come up with 0.25 or 25 hundredths. We would do the same thing here. We would divide by 4 and we would come up with an answer of 145 thousandths. So 145 thousandths would be the answer. Or we can use an equivalent ratio. Write and solve the equation stating the ratios are equivalent. Let n represent the unknown. So again, setting it up just like what we've done with all the other problems. We don't know what the part is, but we know the whole is 58. The whole would be the 100%. We want to find the 25 hundredths of a percent. So we would divide 100. We would multiply 100 by 58 hundredths. To get 58, we would need to multiply 25 hundredths by 58 hundredths. And when we do that, we come up with 145 thousandths as an answer.